Now let's check what differentiability of a function is. Derivative of a function at a particular point is the slope of the function at that particular point. So to attain the derivative of a function at a particular point, first of all, the function should have a tangent at that particular point. So how can we say that whether a function will have a tangent at that particular point? We call this the function is differentiable at that particular point. So how do we check whether the function is differentiable at that point? First of all, the function cannot be broken. It cannot be discontinuous because then at that point there can be no tangent. So for a function to be differentiable, first of all, it has to be continuous. Now, after being continuous, for being differentiable, still there are possible cases where the function is continuous but not differentiable. One such example is a graph with a sharp curve. At this point, the function is continuous since the value of fx exists and the limit of the function is the point x. So, why is it not differentiable? The fact is that there can be more than one tangent which passes through this point. All these lines pass through the single point only once and not touch any other point on the graph. So all these lines are tangents, which basically means that the function is having more than one derivative. So we say that the function is not differentiable at this particular point. So the condition required for a function to be differentiable is, first, it should be continuous, which we know by fx is equal to the limit of the function, and secondly, the function should not have any sharp points. And how do we mention this mathematically? This means that the derivative of this point, that is limit of f of a plus h minus f at a upon h, the derivative of the function at that particular point should exist. So we take to see it, what we basically do is we take the derivative of the function at a point before it and after it. So suppose there is a graph and we want to find the derivative at this point. We take the derivative of the point before it and after it and come back. Suppose they have both the same tangents, that is, since they are very close and if they are continuous, we can say that they have the same tangent. So both have a derivative equal to each other. So the derivative at the point is does exist and is equal to the tangent, the slope of the tangent shown here. But in the case of any sharp point, the point before it will have a slope very different from a point after it. So the difference between these two is that the left hand derivative and right hand derivative of that graph at that particular point is same, whereas in this case the left hand derivative and the right hand derivative of the same point is very different. So for a function to be differentiable, it has to be continuous and it should not have sharp points, which basically means the left hand derivative of the function should be equal to right hand derivative of the function. So the conditions required for a function to be differentiable is it should be continuous and the left hand derivative should be equal to the right hand derivative of the function.